All right, so I'm briefly going to go over this. I'm going to be posting this to Canvas later today, along with the Builder Lab. So as I've spoiled to some people who were in here at the time, the plan at the moment is to assign both of them today. The Builder Lab will be due this Friday. This project will be due a week from Friday. There is plenty to this though, and I'm not giving you the API or a code base to start from because I really want to see the design process. There will also be time to work on this in class at least one day this week and next week. And that will allow you to get your questions answered outside of office hours. So hopefully this isn't too bad, but I will query the class to see what you think about this at the end of this. I think this is a pretty fun project. But a couple other professors I've shown this to said, you better give them some starter code. So I wanna see how it goes, because I think that, especially in this class, the design is really what's the class is about. So you're gonna be designing, I've probably spoiled this at some point, an airline ticket purchasing app, something like Google Flights. So you have a boss, she's come to you with some instructions about what needs to be done. She says the design and flow of the software should be clean and easy to use. Clients come first. User experience is a cornerstone of the company. Code should be extendable. We're just making a prototype right now, and we don't know between this prototype and the final release what things will need to be changed, modified, extended. So because it is especially likely to change in the near future, even the prototype needs to include the design patterns that we've talked about: strategy, decorator, and builder. So a reservation is going to have all of this information in it. We need to know how many tickets are part of the reservation, because you know you can make a reservation for multiple people. Like a family can have the same reservation and they all board with their own separate tickets, but all on the same app. You just swipe to the next ticket, swipe to the next ticket, swipe to the next ticket. So a reservation can contain an arbitrary number of tickets. I cannot click it. Sorry. So can contain an arbitrary number of tickets. We need to know the total cost of the reservation, and that's going to be a sum of the cost of all of the tickets. And each ticket is going to have some factors that influence its price. Each ticket may come with a particular seat class, and or there may be some checked bags associated with each ticket that can add to the cost of each ticket. We need to know the aircraft that you're flying on. So the aircraft will have some kind of name, a number of rows, a number of seats per row. We need to know the number of layovers in this trip. We need the associated airport codes and the hours and minutes of each layover so that you can see on your ticket, here's the layover, here's how long you have at that stop, here's where you're going to be. We need to know the date and time of the flight, the source airport code, the destination airport code, the airline that you're flying. And then for each ticket, we need the full name of the flyer, date of birth, the seat class that's either going to be first class, comfort, or economy. We'll give them 3 options. Each of them may add to the cost of the overall ticket and the reservation as a whole. We need the seat number associated with the ticket, which we'll need to map to the airplane to make sure that it's legal and in bounds there. There's going to be a particular boarding class. I guess that should also affect the cost of the ticket as well. So depending on when you actually get to board the plane, do you get to board first or second or third or fourth? There's also an optional number of checked bags per ticket in the reservation. So how you actually design this is going to be completely up to you, except that it must use at least one instance of strategy, exactly at least one instance of decorator, and at least one instance of builder. I have some hints down here to give you a sense of where you might want to include them. Along with your code, you'll submit about a 1-page write-up. Things to know about me: I don't care about length. If it's half a page, I don't care. If it's 3 pages, I don't care. The question is, does it answer the associated material? If you can do that in a short period of time, don't fluff it out and include fluff language just to make it a page. I'm not going to care about it. Just make sure that you answer the questions in however much space it takes you to do so. I give you an example of about 1-page single space because that's about how long I think it would take me. If you write very differently from me, that's perfectly okay. But you need to explain how and where each design pattern is used. So this is going to be used by the grader to figure out exactly where should I look to see if this is implemented correctly in your code. So you'll have a strategy section that tells you where you can find strategy in the code. You need class names and line numbers. You need to state how it's used. So note the associated classes, how it's split up. Talk about the benefit you get from using the design pattern. So especially talk about the extendability, what happens as we add more of a particular kind of thing. Let's say we add more airlines to our ticketing system. We come up with legal agreements with more airlines. How does that get reworked in the code? We come up with some new airplanes. We add some airplanes to the fleet. Maybe a new model is released that we include and allow as part of our reservations. How easy is it to modify that? You'll also give a short description of any drawbacks, additional considerations after you have all three patterns in your code. Here are the hints. The builder pattern should be used to construct the reservation. It should not matter the order we give this information. We basically just need to communicate with the director. The director is going to make the associated changes to the reservation. So just make sure that all of that is intact in your code so that we can know whether or not you have a complete reservation or not, but you can supply the information in any relevant order. Decorator will wrap your flight information with any ticket customization. So you should be able to wrap with something like an additional checked bag. You should be able to wrap with something like a new kind of seat. So instead of you wrap it with the first class seat instead of the regular seat. So you can use decorator for one or multiple of those things. Then you want to use the strategy pattern whenever you have any behavior or algorithm. So something like if at the very end of the reservation, you wanted to actually fly the aircraft for some reason. I can't think of why that would absolutely be necessary, but you can, the boarding process would also be an algorithm for that might vary depending on the airline. So you have a little bit of freedom in the design to figure out how are you going to incorporate strategy, but you can do that. You'll use inheritance hierarchies for each of these different things. Some of them may be split. If you're using strategy, then we have a couple of different hierarchies that go with it. We have the actual hierarchy and the behavior hierarchy. So you can use your creativity for names. This is very much not like the labs you've had so far that require you to program precisely to an API. This is a design-based lab where you have the ability to express your freedom. I just care that you're utilizing the design patterns and that the end goal is that this is a very usable application. I should know what I'm doing at all points. The communication with me should be very clear. So grading for this, it'll be out of 100, but I'm multiplying it by 3 so that it has the same weight as the strategy lab plus the decorator lab plus the builder lab all together. So this has triple the weight of a usual lab, which means that it's very, very important and you should take it seriously. It's broken down into 3 categories. We have functionality and design. So how easy is it to use your application? Do I have to look up documentation? Do I have to guess at any point to figure out what is it that I'm supposed to be inputting right now? What is it that I'm supposed to be doing? What are you waiting for? Is it clear? The functionality, do you include all the necessary components and features? If I do something wrong, does your code break elegantly? Or does it just crash with no information? Then most or almost half of the grade is the correct implementations of each design pattern. Finally, you'll write a test suite. I give you, I'd say about 20 tests, but I'm not looking for exactly 20. Again, I'm looking for the quality of the tests. So write quality tests. You're more likely to get a good grade if you write 15 good tests than if you write 150 bad tests. So the usual questions, are they going to reveal bugs? If the test fails, how easy is it to go back to the code and figure out what was wrong in the code from the failure of the test? Finally, 10 points for documentation. You should make sure that all code is documented with JavaDoc, file headers for every file, method comments for every method. As part of this, you need to specify any parameters, returns, and especially important here is the addition of preconditions and postconditions. So what needs to be true at the start of each method in order for that method to even be called? What needs to be true what is guaranteed to be true when the method finishes? If we go through this process, what do we know about the state of the application? Finally, you'll zip up SRC and test directories and submit to Canvas. Do people have any questions to allow you to get started?
The strategy stuff, are those methods gonna be like imaginary methods? There's like a boarding and a flag method. It's like,
Yeah, you can design that however you want and put it into that process. Yeah, yeah. I'm less concerned with the overall functionality or if it's particularly realistic than just that you implemented something with strategy that makes sense within the world of a reservation system.
and all the interactions can happen.
Yeah. Yeah, nothing with files, nothing with, it can all happen in the terminal. I want to make this as easy as possible with the exception of the design portion, which is really important for this class, and the design patterns that are really important for this class. Those are the things I'm especially going to nitpick. Everything else is just kind of freedom. This should be a fun project. You should feel like you're making something real, maybe for the first time. Something that's your own brain baby.
Is this something that we're working on alone, or we can work with a couple of people?
Let's do it alone, but if you want to talk to people about your ideas, you're welcome to do that. I would not share code between people or exactly how you implemented a particular design pattern, but you could say something like, I designed this for my strategy, and these were the classes that I made for that. This is the design that I used. You can talk at that level amongst your peers, but it should be individual because I want each of you to be comfortable with this entire process. Things to note as you're getting started. Spend significant amounts of time designing this. Do not sit down at a computer to start. Draw out UML diagrams. Start thinking about what are all the features and functionality. You should be able to describe your code at a high level before you start programming. If I were to walk up to you and say, what does your application do? You should be able to walk me through the entirety of what it does. If you can't do that, keep designing. If you can do that, now you can start thinking about coding. But you should really have an understanding of the entire hierarchy of the project before you get started. And if you don't do that, you're going to find yourself in a world of hurt when you are actually in the middle of programming, because you're going to be changing your mind about what happens or realizing there's something you haven't considered, and it's going to completely reinvent your solution, possibly from the ground up. You're going to have to go through and make big changes to your design partway through, and that is a hugely painful process. In fact, it's probably going to be easier to just start from scratch at that point, rather than trying to go fix everything that needs to change in each of 12 different classes. And you're gonna miss one, and it's gonna cause a test to fail, which is gonna cause a future headache, which is gonna cause a whole debugging cycle. You can waste hours of your life with just something you haven't thought of yet. If you incorporate it into your design when you get started, it will make your life significantly easier. So tomorrow's class, we're gonna switch from this back to the factory pattern for the rest of today's class. But tomorrow's class is going to be a work day. I highly recommend that people come in ready to get started with that design process. And I will start walking you through some of my ideas for how I would do this. And you can talk to each other about the design, pitch your design ideas to other people in the class and see if they buy or have some feedback. You can pitch it to me and I'll see if I can poke some holes in it for some additional things you should be thinking about. But aim to be through that design process in the next few days so you can get started with it. If this is due next Friday, I would think you'd want to be starting coding by the end of this week. Because there's a lot here. This is probably going to be a, I don't know, 15, 20 class project where most of those classes don't do very much. If you have a particular concrete class that is a particular airplane, it's going to have 3 fields and 1 behavior, possibly. So something like, it's gonna have a name, a number of rows, a number of seats per row, and a fly method that tells it how it flies. Maybe you have a jet-powered engine, a jet-powered plane, maybe you have a propeller-powered plane. Maybe you have a horizontal propeller-powered plane and a vertical-powered plane for something like a helicopter that has a single row with 2 seats in it. But you'll want to think through all of that design before you get started. Any questions about the project? Any pitfalls that you see getting started with it? Is everything clear?
Spaceships.
Yeah, why not? A reservation to, go to the moon? Sign me up.
Will this document be on Canvas?
Yes, yeah, I'm gonna upload it to Canvas, but I just wanted to get the process started so you can start thinking about the design as soon as possible. Yeah, that and the Builder Lab will be uploaded to Canvas later today. I know there's a lot of work, yeah.
Know what your office hours are, we have a TA, right?
We do have a TA.
What was his office hours?
1 to 2, he doesn't come in every day, so if you can let me know, I can let him know to be here in person on those days. He is also available, you can reach out to him on Discord. You can reach out to him via email, he's very receptive to both of those. I can get that information to you if you are curious about that information as well.
See in the 212 Discord channel.
He should be, he's in basically everything. And I can get you his tag. We really should be using some kind of name system in our Discord so that it's not just,
You can change your server.
yeah, you can, but I think we should have a particular requirement for the server to have at least like a first name, last initial, or something that identifies who you are. So you can tag people when you need them. And not have to memorize their name.
Was the Discord in the syllabus? I think I will record it.
I'll throw an invite on Canvas as well, along with everything else this afternoon, so that people can join the CS Discord. Other questions or concerns about getting started? I highly recommend doing the design process with people. The design does not have to be 100% unique to you. I'm more concerned about going through that design process and then making sure you implement it by yourself so that you get that. But there should be a wider design discussion about how do we make this make sense?
So,
Yeah,
like the plane and the airline and the tickets all make sense, but like, I guess the destination's throwing me a hitch. Is it just like, you're choosing like, do you want us to program states in there?
you're just gonna have a few options.
Just a few.
Yeah, I would not program every possible airport or make a class for every possible airport. We'll start with a very small reservation system that, maybe flies to the major airports in Washington and Idaho and Oregon, where then the major ones being, 2 from each state. You can fly into Seattle and Spokane. You can fly into Boise and, I don't know, what else? Pocatello, Idaho Falls. You can fly into Portland and Eugene. I don't know, so you can just start with those associated airport codes. I don't even care if they're realistic. You can make up your own airport codes if you want to. Just make sure that you have a few of them as your concrete classes, and then that's it. You can do MOO for the moon, I don't know. Is there cows on the moon? The moon is made of cheese? I don't care how realistic it is, as long as the system is in place and you show the design pattern. You should have some fun with this. If you want to make some jokes in it, perfectly fine. Have fun with it.
Cheese airlines.
I'm down for it.
World destination cheese. That's what's gonna be my thing. All these airports, all these locations, they're where the best cheese is. Why? Is that one?
Exactly.
You know, like food service.
I was thinking, chance to lose your luggage is increased on airline. Sir,
That could be a behavior.
yeah.
All right, let's figure out where we were. We were just starting to talk about making Ethan's pizza, if I remember correctly. It's been so long that I kind of just want to go through everything at a really quick process, really quickly. So let's start back at the beginning. I'll just leave it here before I change this back to extending rather than duplicating, so that I can quickly arrow through the different slides. So we were talking about the factory pattern. You remember anything about the factory pattern? It's been long enough. Yes, we were doing lots of pizza. So we were getting around using the new keyword because the new keyword allowed us to only use what we can do in a method, and we instead want the power of a class inside of our object construction. Be careful not to hit my touchpad as I do this. So we can't extend things like if we wanted to go on a picnic, then we make a mallard duck. There was this whole if, else if block that we wanted to do something with. So we first threw it into, it's like, if we wanted to do it in a constructor, we could kind of do that. But now we had this order pizza method. We had this if block inside of the order pizza method. And then we decided that we were gonna make our own class out of this. So we talked about encapsulating object creation into its own class. So we moved it into what we called a simple pizza factory that was capable of returning one of these many different kinds of pizza. So it could return a cheese pizza, or it could return a pepperoni pizza, or it could return a clam pizza or a veggie pizza. So what was the benefit of this? Is that we could call this anywhere in our code. We didn't have to have that if, else if block wherever we made a pizza. We would just call this class, which gave us all of the options. And we could pass in a string that was the type of pizza that we wanted, and it would instantiate the appropriate kind of pizza and return it to us, which seemed very nice at first. But then we decided that we wanted to make New York style pizzas and Chicago style pizzas for each of the different kinds of pizza. So we wanted to be able to make a New York cheese pizza, a Chicago cheese pizza, a New York pepperoni pizza, a Chicago style pepperoni pizza. So to do that, we wanted to pull it back into a method, and then we were doing some pretty weird stuff to that. So let's take a look at what exactly we were doing. So we made a pizza store class, and the pizza store class had a factory, the simple pizza factory, associated with it. When we instantiated a pizza store, we passed it a kind that was like the New York style pizza factory or the Chicago style pizza factory. And that way our store was either a New York style store or a Chicago style store. And we could make two different pizza stores of each of those types. So this was, again, not yet a design pattern. We haven't gotten all the way there. But in our pizza store, we could order pizza. We could order pizza from a pizza factory that we built already. That pizza could be then prepared, baked, cut, and boxed, because that was all done the same way. So that's why it's in the super class here, the pizza super class, rather than each of these smaller ones. Rather than the concrete classes like the cheese pizza, the veggie pizza, the clam pizza, or the pepperoni pizza. So to actually get this New York style pizza factory and Chicago style pizza factory, we were going to bring these back into the order pizza method. So instead of having just a simple pizza factory, that becomes an abstract class. And now we can make a New York pizza factory, a Chicago pizza factory, or a California pizza factory. The downside that we saw here is that it's the client's responsibility to tie these together. So we need to make a pizza store, and then we need to tie together that this is a New York style pizza store from the driver class. Does that concept make sense still? That we don't want the client to be doing any of this work. We want the design to be in the actual code and implementation that we make. The client should only be responsible for picking what they want, not actual code for tying it together. It's like the scam that is bake it at home for your pizza. Such a scam. Why would you do that? It's gonna cost as much in energy to bake the pizza as the difference between a prepared pizza and the pizza that I don't know. It's always seemed like a scam.
Hot burgers, you put it in the smoker and bake it that way, it's pretty cool.
You can customize it a bit. Yeah, you can make it the way that, you can bake it the way that you want it that way. Sure, I can understand that.
Smoked pizza's super good.
Yeah. So this gave us a new framework. So pizza should be made in the pizza store class. Franchises should have the ability to make a New York style, Chicago style, California style, whatever the preferred regional style is. So we move create pizza back into the pizza store, but as an abstract method. The subclasses of the pizza store can decide on the regional style. So all stores look the same, except that they make different kinds of pizza. The benefit from this is these subclasses can decide things. They can decide things like, we're going to make a New York style pizza or a Chicago style pizza. The pizza store doesn't have to decide that. It can be instantiated as one of those subclasses. And that way, the create pizza can be put back into the superclass since you always create the pizza the same way, regardless of the regional style. Then we had some code examples. We can see that still create pizza has that if, else block. So we don't need to put that a bunch of places in our code, just like before. We talked about how to declare the factory, the old way versus the new way. We talked about the general order of events. This is the last thing we did, right? We said that there were two people, Ethan and Joel. Ethan wants a New York style pizza. Joel wants a Chicago style pizza. Both need a particular instance of a pizza store. Ethan wants to go to a New York style pizza store. Joel wants to go to a Chicago style pizza store. Once they are in their separate pizza stores, they can both call the order pizza method. They can pass the type of pizza they want. Maybe one wants cheese, one wants pepperoni. The way that the pizza is actually created is the same between those. It's just a matter of whether it's prepared in one way or prepared in another way. So when an order from the New York pizza store is received, it goes through the particular steps to make the New York style pizza. When an order is received from the Chicago pizza store, it goes through the steps to make a Chicago style pizza. You don't actually need two separate locations for that. It just needs to know which store did the order come from. The order pizza method doesn't need to know what kind of pizza was created. It just knows it's a pizza. If you're gonna cut a pizza, it doesn't matter if it's a New York style pizza or a Chicago style pizza, you still cut it. You still box it, you still do everything that you would do to a pizza. So let's actually go through the logic and follow Ethan's pizza as it is made according to the code. So the code that is called, we need to create a New York pizza store. So this creates an instance of a New York pizza store, which is a concrete class from the pizza store interface. Now that we have a store instantiated, think of it like opening a new store, we can take an order in that store. So we can call order pizza on that particular store. So we say New York pizza store dot order pizza because order pizza is a method inside of the pizza store class. This happens to be a New York pizza store, so we override the does nothing order pizza with the order pizza from the New York pizza store. So we know that it came from a New York pizza store, so we can prepare it in the New York style. That scrolls too fast. The order pizza, then we'll call the create pizza. So think of it like we have a waiter that takes the order, writes it down on a piece of paper, and then hands that piece of paper to the baker. Since it came from the waiter who's associated with the New York pizza store, the baker knows to create the pizza in the New York style because it came from the New York pizza store. So the pizza is created in the New York fashion, then it returns it to the order pizza method. The waiter can then prepare, bake, cut, and box the pizza to hand it back to you. Note that the preparing, baking, cutting, and boxing is the same no matter what the class. So I think now we can take a look at the actual code. All right, so what does the actual code here look like? So the pizza class is abstract, that makes sense, right? If I say to every student in here, draw me a pizza. It won't necessarily be the same, right? Maybe someone draws a pepperoni pizza, someone draws a cheese pizza. So it makes perfect sense that the pizza is abstract. Someone might draw a circular pizza, someone might draw a square pizza. But all pizzas have a name, a particular name of the pizza, like cheese. A type of dough, a type of sauce, a list of toppings. All pizzas have these things, so we can define them in the abstract superclass. The prepare method is also always going to be the same. We prepare whatever the name happens to be. We can toss the dough, add the sauce, add the toppings, and then eventually bake the pizza, assuming that all pizzas are baked the same way, not perfectly realistic, but if they were baked the same way, then we could define them in the abstract superclass. We could cut the pizza, box the pizza, and have a method to get the name of the pizza. All of this is the same for all kinds of pizza. So this defines everything that is shared in common between all of the different kinds of pizza. Any questions on the superclass? What information are we missing here? What needs to be defined in the subclasses that isn't defined in the superclass?
Double sauce toppings.
Yeah. They aren't instantiated, right? We don't have a name equals something. We don't have a dough equals something. We don't have a sauce equals something. We don't know what the toppings are. So we need to define what those are. So here's an example of the New York style cheese pizza. So we set the name to be New York style sauce and cheese pizza. We set the dough to be thin crust dough because New York style says we have thin crust. Sauce is marinara sauce for a cheese pizza. We want to add the toppings. There's just going to be one. Reggiano cheese. Great, that's a whole pizza. Here's the Chicago style cheese pizza. The name is a Chicago style deep dish cheese pizza. The dough is extra thick crust dough. The sauce is plum tomato sauce. And we will add shredded mozzarella cheese as the one topping. Note that with the Chicago style cheese pizza, we want to cut it into square slices so we can override the cut method to cut it in a certain way with extra instructions for how to cut this pizza. So you can see how this structure allows a lot of flexibility to make different kinds of pizzas. We can write a driver class for this that can kind of follow what Joel or Ethan would go through to be able to make their pizzas. So we can make a New York store and a Chicago store. We can then make a pizza. We want to order from the New York store a cheese pizza. We can also walk into the Chicago store and order a cheese pizza from the Chicago store. And you can imagine that the names for these pizzas would be the equivalent of the New York style cheese pizza name and the Chicago style cheese pizza name because they were ordered from the different stores. When you make a New York pizza store or a Chicago pizza store, you're making one that can only make New York style pizzas or Chicago style pizzas. Questions on the code, what that looks like?
Can you go back to how it was decided whether it's Chicago, how was it in the store subclasses?
Yeah, well, it's in the type of store that you make right here. So we have a New York style store and a Chicago style store. Whichever store you call the order pizza on will make the New York style or the Chicago style.
It was in the subclass.
Yeah.
They each had their own method for pizza.
Order pizza is in the super class, but since we know it's a New York style or a Chicago style, then we end up with all that we need to do is set these. The order pizza does not know whether it's ordering a New York style or a Chicago style, but since it's that particular kind of store, then it calls it on the appropriate subclass. So we don't need a separate order pizza method for each, since the ordering is exactly the same. The only thing that changes is the actual ingredients, which are constructed in the subclasses. Any other questions? So now we have more of a factory pattern style design. What issues do we see with this? Do we see the major issue that we've created? Yeah?
The thing I was thinking, all the pizza are concrete. You have to, every time you're making a pizza, you have to define that pizza.
Yes. What happens if we have 4 different kinds of pizza, cheese, pepperoni, clam, and veggie, and we add a new location? So we had New York and Chicago. How many pizzas do we need to make if we add a California style? 4 more subclasses. All right, great. Now we have a California with 4 of those subclasses. Let's say now we want to make a buffalo style or a Hawaiian style pizza. How many classes do we need to make now? 3 classes, 1 for each of the New York style, the Chicago style, and the California style. What happens if after that we add another new location, and then we add another new type of pizza, and then we add another new location, and then another new type of pizza? How many subclasses are we creating? It's getting kind of unwieldy. It's not hard to make one of these subclasses, but when you have to make 10 of them, it's really annoying. So let's abstract this concept, and we're going to learn about the abstract factory pattern that's going to help us to be able to condense this down and solve this problem. And again, you see this a lot in design patterns. You solve one problem, you create another. You solve that problem, you create another. So factory method encapsulates object creation by allowing the subclasses to decide which object to create. We saw this with the New York style pizza. Someone walks into a New York pizza store and says, I want a cheese pizza. They don't need to specify a New York style cheese pizza because the order is coming from a New York style store. So the subclass, the store that you're in, decides what kind of pizza to make. So here are the creator classes. Nope, I have to zoom back out. You then can see that we make a bunch of types of pizza that all they inherit from pizza because it's no, they extend from pizza. Because it's an abstract class. It's not an interface, it's an abstract class. So we've seen this before. This is a parallel class hierarchy, where whenever we want to make new locations, we need to add locations. Whenever we need to make new pizzas, we have to make new pizzas. So we have a lot of different subclasses going on right now, but if we notice that we have products and we have creators, then wouldn't it be nice if we could use composition rather than inheritance? We could split them out and that way only make one new class when we expand to a new location, have a new type of pizza we're going to create, or we create a new kind of pizza. So instead, I guess you can kind of see it here where we have our creators and our products. The concrete products inherit from product, and the concrete creator inherits from the creator. Great. Imagine without using the factory pattern. I think we've kind of gone over this, but you can see exactly what happens as we expand the number of subclasses. You can see how bad this looks without the factory method. Just the sheer number of ifs and else ifs and elses, and you can imagine how that would explode anywhere in your code where you tried to create a pizza. So that's a good motivation for why this design pattern is necessary. Yeah, you may end up with a lot of classes at the end of the factory pattern, but it's at least better than this, right? So this brings us to a principle in object-oriented design called the dependency inversion principle. This means that we want to depend on abstractions rather than concrete classes. This may sound a lot like the one that we saw before, program to an interface, not an implementation. How are these different? There's a kind of coupling that goes on here where we have a high-level component and a low-level component that are tied together. If we depend on the abstractions, then we can either split this apart or we can duplicate and make more of the lower level things because the design is in the abstraction. The design is not in the concrete class. If the design ends up in the concrete class, then we need to make a bunch of concrete classes once we have more ideas. If we've designed an interface or we've designed an abstraction for that, then it allows us to be able to add more of those that adhere to the abstraction.
Like your abstractions, interfaces are like framework.
Yeah, yeah. So you want to make sure that whenever you want to add a new thing, that you only need to make one class. That's true across all the design patterns we've seen. And so even with the factory pattern, we haven't fully done that yet. Because whenever you add a new kind of pizza, we need to add multiple classes. Whenever we add a new location or a new style of pizza, we need to add multiple classes. So in this case, the high level component is the pizza store and the low level component is the pizza style. So our high-level components should not depend on our low-level components. Does our pizza store depend on the particular pizza styles? No, we can add or remove them at will. If our pizza store broke, if we stopped offering a pepperoni pizza, that would be bad. We'd be programming to the lower level component. So let's apply this to our pizza store. The way to think about this ends up being bottom up rather than top down. Instead of thinking starting at the pizza store and then working your way down, if you can start with what is this particular kind of pizza and then build up to creating a pizza store that encapsulates and uses that, then your code will be much cleaner, better, easier, etc. So rather than starting out thinking and designing, I need a pizza store, you want to think, my store needs to be able to make a bunch of different pizza types. Right? That's bottom up rather than top down. That allows you to think, well, if they're all just pizzas, they should share an interface. After you create the interface, you have an abstraction for it. So you can design the store without having to worry about the actual pizza classes. And this becomes the intelligent way to design around this. You want to be able to say, I want to be able to design the store without even thinking about the concrete types of pizza. I want to be able to design additional kinds of concrete pizza without reworking the pizza store. And that arises from doing this kind of bottom up or very concrete out ways of thinking. If you just start with, I need a pizza store, and then start programming, you're going to have to do some kind of rework. Because you're probably going to be putting the concrete kinds of pizza inside of your pizza store. So that when you need to expand or come up with additional kinds of stores, you'll have to go through an entire reworking procedure to pull it all out. Basically starting from the very beginning of this lecture, making all of the associated changes to implement the factory pattern as you figure it out. You can get around that from the beginning by thinking bottom up. Does that make sense? So we have an abstraction for the pizza store, we have an abstraction for the pizza, and then we have all of our concrete pizza types. So if you draw a diagram that looks kind of like this ahead of time, then you can design around even this simple diagram to see where your abstractions are. So this is the kind of thinking that you'll want to apply to your project as well, thinking about where are the abstractions. You don't want your concrete classes to rely on your abstractions. You want to decouple those as much as possible. Some things you should keep in mind if you're applying it in general, no variable should hold a reference to a concrete class. Notice that nowhere in the pizza class is there a pepperoni pizza or a New York style pepperoni pizza variable of any kind. In the abstractions, you only talk about abstract things. The keyword new creates a concrete class. If you want to be able to create an abstraction, like I just want a new pizza, I don't know what type it is yet, but I still need it back. Then you can use the factory pattern to be able to figure that out and get around using the new keyword. No class should derive from a concrete class. If you derive from a concrete class, you end up depending on it. So if you extend a concrete class from another concrete class and override it, then you depend on that initial concrete class. You can't break easily or extend easily. So you want to make sure that wherever possible, you have interfaces or abstract classes that allow you to create additional subclasses to that without the coupling, without the dependencies that exist. You shouldn't be overriding any implemented method. We saw this back when we were talking about the strategy pattern, when we overrode the fly method into kind of a no fly. It's like we took this idea that was already implemented and we said, yeah, we're gonna override that to do nothing instead. So don't do that ever. If you do this, the base class wasn't an abstraction. Even if it's part of an abstract class, if you define behavior in that abstract class, you should not override that in classes that derive from it. You should leave it as abstract in the concrete class and then let in the abstract class and then let the concrete classes decide that behavior. There's always a beware to this. These are guidelines. So you still can do this. If you have 20 subclasses to something and you need one of them to override to do nothing, you're either writing 19 implementations or you're writing 2 implementations. Usually the 2 is better than the 19. But if in the future you're going to extend, then maybe it makes sense. It's always project dependent. You should not necessarily strive to follow these all of the time. It's going to be impossible to do so. But you want to have a reason to break them in your design. So these are the general guidelines. If you need to break them, it's because of something specific, but you've thought about it. That's the most important thing, is that you've thought about why you're breaking these rules. How are we doing? Any last minute questions I can answer? We're basically out of time, but I'd be happy to clarify anything from this discussion.
The Chicago like cut that then goes against this.
Yes.
But it makes sense.
Yeah, there's a basic way to do cutting, but we're overriding that to cut it a different way. But that's because only Chicago style pizzas are going to be cut into squares. Otherwise, every other one that cuts them into triangles we'd have to specify cuts into a triangle, cuts into a triangle, cuts into a triangle, cuts into a triangle. But you're absolutely right that we've at least thought about that design to say there's only one regional style that cuts them into squares. So you can define cuts them into triangles as the default and override that the one time it cuts it into a square. That's an excellent example. All right. I'll get stuff uploaded to Canvas so that you can get started on your work. And we will have a work day tomorrow so that people can get started and ask questions. Yeah.
Will there be an API for the build company or that?
Yes, it's going to be very similar. The builder lab will be very similar to the last 2 you've done.
Okay, thank you, so.
Yeah.
Give me a Rudy, a search. Take that out. Yeah, look at the booty, web page, so it's not that HTML that.